All right, y'all. Like I said, tonight, 5E, correlation and causality. All right, y'all. So, first of all, we will define correlation. So, y'all, a correlation exists between two variables when higher values of one variable consistently go with higher values of another variable, or when higher values all right, let me let one in. Or when higher values of one variable consistently go with lower values of another variable. All right, so y'all, let me show you what they're sort of talking about. Say you got a little graph here. Um, so I've got an example where they show you diamonds. So the price, so the size of a diamond and the price. So what we mean between two variables, when higher values of one variable go with higher values of another variable. So the size of the diamond, let's just say we got 1 carat, 2 carat, 3 carat, 4 carat, 5 carat. And then the price could be something like 1,000, 2,000, 3,000, 4,000, and so forth. So as the size of your diamonds increases, then generally the prices will increase. And you'll get some kind of a little scatter diagram. But this is what I mean by when one size gets higher, then the other prices are all getting higher also. Okay, so that would be a correlation in which both of them were getting higher. Okay. All right, y'all. So let me think of one. So say this right here is the price of gas. And over here is how many gallons people buy. Okay, and we'll start this off, say at 2, 3, 4, 5, and 6. And in gallons, I'll start out, say 20, 15, 10, and 5. So usually, based on the price of gas, if gas is really cheap, people might tend to fill their tanks up more. Okay? So even around 2 something, you might get sort of like prices jumping all around. But the higher the gas goes in price, you're going to notice people are going to buy less gas due to the price. So what this gas is getting higher, the gallons bought is getting lower. So this would be a case where something's getting higher and it consistently goes with something going lower. Okay? So that's what we mean by both of them being high or one being high while the other one goes lower.
So is the gallons graph, is that a correlation as well?
What now?
I'm saying, like, as the gallons get higher, the people pay less. Is that also a correlation?
True. Hmm. And usually you'll see those will be pretty much strong correlations if you notice them prices getting higher, okay? All right, y'all, we'll look at some of them. I just want to give y'all sort of like a brief idea. So what that chart was there, that's what we call a scatter plot. So a scatter plot is a graph in which each point represents the values of two variables. All right, let me let one in. All right, y'all, so let's look at relationships between two data variables. So like on that first example I did, the size of the diamonds and the price of the diamonds were the two variables in that example. So we can have certain things happen on these scatter plots. We can have no correlation. So no correlation happens when there is no apparent relationship between the two variables. So they're either both not going up or one's going up and one coming down. Um, so no correlation would have no pattern, okay? You might not be able to tell if it's getting higher as one goes higher or if it's getting lower. So they're sort of scattered around. A positive correlation is when both variables tend to increase or decrease together. So that'd have been on the diamond example. The price went up. As the weight went up, the prices went up. Okay. Um, Also, you can have two things going down. and that'd be positive. Negative correlation was like the gas example. As the prices went up, um, the usage or how much we bought would go down. So that'd be a negative correlation where one increases. So one variable increases while the other decreases. All right, then they talk about the strength of a correlation. So the more they form a line, basically, is the stronger they are. Okay. So the more closely two variables follow the general trend, then the stronger the correlation. So, like I said, if it was a perfect correlation, then all the data points would lie in a straight line and they would increase sort of geometrically, okay? Or they would both sort of decrease more close to a straight line. So, y'all, I'm going to pull up an example of a positive correlation, like on the diamonds, and then they got one with a negative correlation, okay? So let me pull these two up. So this is like the one I did with the diamonds. Um, but notice as the weight of these diamonds is getting heavier, the price in dollars is generally increasing. And you can almost see that it wants to form a line sort of going uphill to the right. Now you got a few that are way up here. We would probably call them outliers since they're not following that general trend, okay? So that's what we're talking about on a positive correlation, where they both either increased or they both would have decreased. Next, I'll show you a negative correlation. So on the bottom, you got life expectancy in years, 50, 60, 70, 80. On the side, you got infant mortality. So that's deaths per 1,000 live births. So notice as the life expectancy is going higher, the infant mortality is actually getting lower. It almost looks like it wants to form a line going downhill from left to right. Okay, so that would be negative correlation. Alrighty, y'all. So let me get us back on my pad. Okay, so we're going to look at possible explanations for a correlation. All right, so the first possible explanation, the correlation may be a coincidence. Okay, so an example they had on this, the stock market tends to rise when a team from the old pre-NFL wins the Super Bowl and falls when a newer team wins. So as of 2017, the success rate of this predictor was 80%, which is better than any professional stockbroker. All right, y'all, so let's look at number 2. Both variables might be directly influenced by some common underlying cause. Okay. So an example they had on that, when ice cream consumption is higher, there are more incidences of death by drowning. All right. Third possible explanation. One of the correlated variables may actually be a cause of the other. And note that even in this case, it may be only one of several causes. So it might not be the main cause, but it could have an influence, and there might be several things that are influencing the correlation. All right, y'all. So not many definitions tonight. So I'm about to get this homework ready and see what we do with it. All right, y'all. So I'm going to share the screen for our homework here. So y'all got like 6 questions tonight. So I've got chat open. So let's see what we do with these. All right, y'all. So the first one wants to define and distinguish among positive correlation, negative correlation, and no correlation. And then how do we determine the strength of correlation? So first off, they want us to define positive correlation. So y'all got A, B, and C, and D to pick out of. So does positive correlation mean that two variables tend to change in opposite directions, with one increasing while the other decreases? Does positive correlation mean that both variables tend to increase or decrease together? Does positive correlation mean that there is a good relationship between the two variables? Or does positive correlation mean that there is no apparent relationship between the two variables? So, y'all, of them 4 choices, what would y'all pick for the definition of a positive correlation?
A.
All right, so I got an A and B. So let's see. So A meant they went in opposite directions, and B says they tend to increase or decrease together. So I will say this. Remember on positive, we said that they would either both increase together or both decrease together. So y'all on that one, we actually want B. I think the one y'all chose A, I think that's actually going to be your negative. So let's check this one. All right, y'all, here we go. Negative correlation means that two variables tend to change in opposite direction, with one increasing while the other decreases. Negative correlation means that there is no apparent relationship. Negative correlation means that both variables tend to increase or decrease together. We all C was the answer we put for the first one for positive. And then negative correlation means that there is a bad relationship. So Eric, are you going with A? So that'd be sort of like the gas. The higher it went, the less people were buying fewer gallons and stuff. So let's check and see if you're right on that. All right, good job. And then no correlation. Well, it can't be A. We put that for positive. So B says no correlation means that the two variables are always zero. No correlation means that the two variables tend to change in opposite directions. That's what we put for negative correlation. And then D, no correlation means that there is no apparent relationship between the two variables. So what are y'all putting on that? So y'all, I will tell you, no correlation means that there is no apparent relationship. Good job, Erica. There's no apparent relationship between the two variables. And then finally, how do we determine the strength of a correlation? The more closely two variables follow a general trend, the stronger the correlation, which could be positive or negative. The more closely two variables follow the general trend, the weaker the correlation. No correlation is stronger than negative correlation. Positive correlation is stronger than no correlation. So that don't even make sense. Negative correlation is stronger than no correlation. Positive correlation is stronger than negative correlation. And that didn't really make sense. You can have a strong negative correlation and a weak positive correlation. So really on that one, y'all would want to pick A. The more they follow a general trend, the more they get line-like and get closer to closer, making a line. That determines how strong they are, okay? All right, let's see what we do on 2. So we're going to determine whether this statement makes sense or does not make sense. So they're saying there is a strong negative correlation between the price of tickets and the number of tickets being sold. So what that means is, as the price of the tickets goes higher, then the number of tickets is declining over time. So it's a negative correlation because the price is getting higher while the number of tickets is getting lower. Okay? So it suggests in order to sell a lot of tickets, the price should be lowered. That sort of makes sense, right? If you want to sell more tickets, since they're declining as you raise the price, then you might want to lower that price to get more tickets sold. So let's say that makes sense. So B says it makes sense to increase the ticket sales. The price should be decreased since there is a strong negative correlation. And then D says it makes sense. People will not want to buy, will not want to, but more tickets when the ticket prices are lower. I think that should say buy. I think it should say people will not want to buy more tickets when the ticket prices are lower, which don't even make sense. So, the only one that really makes sense would be B. Decrease the price if you want to increase those ticket sales. All right, so let's see. For the following pair of variables, we're going to state what units might be used to measure each variable. Then we'll state whether we think they are correlated. And if we think they're correlated, positive or negative. So the age of a person and time spent on social networking sites. So to measure age, what units would we use? You got years since birth, minutes per website, hours, or degrees Fahrenheit. What would y'all put there? And y'all remember we're measuring age. So years since birth sounds good. So you'll put that in. All right, y'all. So to measure time, what unit would y'all use? Years since birth, hours, degrees Fahrenheit, minutes per website. So we're going to go hours on that. So what do y'all think? Do y'all think as age grows or as age goes up and you get older and older, do you think that time spent on social network is going to go up or down? The older you get, will the time spent on social networking go up or down, y'all think? So yeah, I would think, I think it's going to go down also. I think they're going to use social media less as they get older. So that would be negative, right? You're getting older, time on Facebook and all that's going to go down. So we're going to say a negative correlation. Yeah, it's going to increase as the age decreases. Okay, so they're backwards with what we were saying. But as you get younger, then the more hours will be spent on social networks. All right, so let's try that on this. And for the following variables, state whether they are correlated. If you believe they are, we're going to go positive or negative again. So the height of students and the length of their pants. So the taller somebody gets, usually they got to get longer pants. So that seems like a positive, right? the longer the pants are going to come with. So let's see, what are y'all saying? A, it's definitely right, right? Positive correlation because the taller someone is, the longer those pants are going to get. So negative would mean they're getting taller, but their pants are getting shorter. Okay? So this one definitely both should go up and be positive. Showing not bad. It's almost sort of common sensey type stuff, you know. All right, so they want us to consider this following statement about a correlation. State the correlation clearly, then state whether the correlation is likely due to a coincidence, a common underlying cause, or a direct cause. So we'll explain our answer. So on oh, hang on 1 second. All righty, so over the past 3 decades, the number of miles of freeways in Los Angeles has grown and traffic congestion has worsened. So the more miles of freeway, then the worse traffic is, okay? The congestion's getting greater also. So they're saying there's a negative correlation between the number of miles and traffic congestion. So that would mean as the miles went up, congestion lessened. But y'all, that hasn't happened. We're getting worse on the traffic. So this one's saying there's no correlation. And then this one says there's positive correlation between the number of miles and the traffic congestion. So since they said that the number of miles increases, the traffic congestion is increasing or worsening. So y'all, that's got to be positive on that one, okay? So then, is it most likely due to a coincidence, a common underlying cause, or a direct cause? So y'all, let's see what we get. Most likely due to the common underlying cause of Los Angeles having a very large population. Is most likely due to a coincidence because the number of miles of freeways and traffic is not related. No correlation between the number of miles and traffic congestion, or is most likely due to a direct cause between increase in the number of miles of freeways made the traffic congestion worse. So y'all are saying common underlying cause. All right, so let's see if y'all are right. Good job. All right, so last one. There's a strong correlation between tobacco smoking and the incidence of lung cancer. And most physicians believe that tobacco smoking causes lung cancer. However, everyone who smokes, okay, not everyone who smokes gets lung cancer. So briefly describe how smoking could cause cancer when not all smokers get cancer. So let's see, A, B, C, or D. Not all smokers get cancer because smoking only makes cancer worse, and many smokers did not have cancer before they started smoking. Smoking can cause cancer even though not all smokers get cancer because most smokers stop smoking before they get cancer. Not all smokers get cancer because many people smoke tobacco products that do not cause cancer. Or not all smokers get cancer because cancer is caused by cellular mutation. And while smoking increases the chances of a mutation occurring, the mutation does not occur in every smoker. So what are y'all saying? The mutation one. So that would be D. All right, so let's see what y'all got on this one. All right, good job. All righty, y'all. So let me go back to the pad. All righty, so let me tell you what we got coming up on Thursday. So Thursday we will get into 6A. And y'all, this will start statistics for us. Okay, so Thursday 6A, we start statistics. And on that day, I believe we'll be looking at mean, median, and mode. Okay, so I'll show you that mean means the average. When we look at median, we're going to be looking at the middle. And this will be like data points we're going to be looking at. And then mode is which one happens the most. Okay, so like on test grades, when you find your average, you add them all together, divide by how many you had. The median, you would line your data points up in order, and the middle would be the median. And in the mode, when you look at all the scores, the mode is the one that happens the most on those, okay? So this will get us started in statistics. Oh, y'all, I'm just checking to make sure I got everybody in. So any questions? So tonight was just a pretty short night. We didn't have much to cover tonight. So, like I said, Thursday we'll do 6A. Little more math involved in doing statistics. A lot of things you can find out when we do statistics. Oh, y'all, plus we got spring break coming up. So, any questions for anything tonight? Oh, y'all, so y'all, let me stop this record.